I'm joined now by Dante Lauretta from the University of Arizona and the principal investigator of the OSIRIS-REx mission. Dante, thanks for being with us again on Asteroid Day Live. We really appreciate your time.
It's my pleasure, Stuart.
Now, last year, when you were here with us on Asteroid Day, you were telling us all about the painstaking preparations that you were making for the TAG maneuver and that sample collection. And then in October 2020, you pulled it off. So congratulations on that. Tell me about that day. I'm guessing that was quite something.
Yeah, thanks, Stuart. October 20th of 2020 was the culmination, personally, of over 17 years of work, not just by myself, but as you know, projects like this involve teams of thousands of people all around the globe. And it was exciting, it was nerve-wracking, and it went exactly as we had hoped. It was a really successful sampling event, and we're confident we got a lot of Bennu regolith in our collector.
Were there any surprises at all? Is there anything that you needed to have a double think about, or or did it all just go straight according to plan?
Well, Bennu has been a trickster since we arrived. It's always literally throwing curveballs at us in some cases, and the TAG event was no exception. For me, immediately upon contact, when I saw those images coming down, I was struck by how soft and compliant the surface was. There was really no resistance to our TAG-SAM collection device pushing down into the regolith. I like to use the analogy of one of those ball pits at a children's playground. It's basically how the surface responded. So that was really interesting and informed our knowledge a lot about the nature of these asteroid surfaces.
It's really fascinating, isn't it? Because we've been hearing from other people that that's a product of the weak gravity, perhaps, on the surface there, that the regolith, these broken parts of the surface, act maybe even like a fluid almost.
Yeah, exactly. Very fluid-like response of the surface. And we knew about the microgravity, but we thought that there would be some kind of cohesion between the particles, something that's kind of binding them together. But they seem like they just flow right past each other like marbles. There's no stickiness to the grains amongst themselves.
It's so amazing, these asteroids. The more we get to know about them, the more exotic they are. They're just such fascinating worlds in their own right. And when you got your crop of the regolith, your harvest, you then decided to stow straight away. You didn't need to go down and get any more. That's tell me about that decision.
Right. So 2 days after the sample collection event, we used our SAMCAM instrument to image the bottom of the sample collector. And at first we were getting excited because we could see some large particles that were clearly collected. And then as we brought down the longer exposure images, we started to see that there was a lot of material that was literally spewing out of the collector and into space. And I started to, really panic when I saw that, because I was like, man, this great sample that we collected is now being lost. So we had to expedite the stow procedure to preserve as much material as possible.
Well, as you say, Bennu's always giving you curveballs, but it's now safely stored. So bring me completely up to date with where you are on the mission. You've left orbit now, I think, and you're on your way back to Earth.
Yeah, we went back one last time. I talked to the team and I said, we need to go back and just document what the state of the surface looks like post-TAG after everything had settled down. So on April 7th of 2021, we sent the spacecraft back for one final look at the asteroid. And we brought a great data set down, which showed us very clearly the extent of the surface disturbance. And that was what I called the farewell tour. That was the final look at Bennu, the last chance to collect any scientific data. And then on May 10th of 2021, we fired our main engine thrusters and began our journey back to Earth. And so we're now in interplanetary space, basically on cruise control for the next couple of years.
Fantastic. So the spacecraft cruising home. I bet you and your team are not on cruise control, though. Tell me about the preparations that you're making here on Earth.
Right. So now we transition to what I call the ground game. So we got to get ready to recover this capsule. That requires working with the U.S. military because we're coming down into an Air Force range. So we're dealing with all the logistics of how we get out onto the site and how we're going to collect the capsule and bring it safely to Houston, to NASA's Johnson Space Center. The team there is busy building state-of-the-art curation facilities and some new analytical laboratories. And we're beginning the process with the science team, which is international in scope, involving many nations across the world, on how we're going to divvy up the sample, which laboratories are going to perform which measurements, and how do we really start to address some of our fundamental questions about this asteroid and more generally asteroids across the solar system.
So those analyses that you're talking about, what are the first kinds of things that you're going to be looking at in those samples, and how soon after we get the samples back in a few years' time do you think we'll start getting the results?
Well, my goal is to start getting results on day one. So we're developing a strategy called the quick look sample. We know from our imaging campaign that there were particles even on the exterior of the collection device. And so what I want to do is immediately identify one of those and get it into our electron microscope. The first thing I want to know is, does this look like something we recognize? Is this like meteorites that are on Earth, or are we dealing with a new kind of material? My intuition says the latter, actually. As we've studied Bennu, we've looked at the boulders and the geology, there's some features in there that are definitely not represented in the meteorite collection. We also learned that the boulders, what we thought were the boulders on Bennu, a lot of them are more like dust bunny, really soft, friable, kind of loosely bound accumulations of particles. So we probably broke those up and we have lots of fine-grained dust that we're going to have to kind of piece back together, i.e. what happened to the sample as it came through Earth's atmosphere and was shaken.
Absolutely fascinating. What an amazing little world Bennu has already proven to be. And it is our hope that you continue to make these amazing discoveries, and we're ready every step of the way to hear about them and tell the rest of the world about them. So Dante, thank you so much for joining us today.
My pleasure, Stuart. I'm really looking forward to seeing Bennu at the nanoscale as we move into the final phase of our science campaign.